Reversible and irreversible reactions. So some reactions are reversible, and for those we draw the arrows facing both directions. They can go forward, they can go backwards, but some reactions are not reversible. And so we can look at the type of reaction and come up with reasons. If we have a nucleophilic attack, if that's our reaction, it will be reversible if the nucleophile is a good leaving group. So it'll be reversible if the nucleophile is a good leaving group. And it will be irreversible if the nucleophile is a poor leaving group. So let's see what I mean by that. So this is an example of this is our nucleophile. Here are our electrons. They attracted themselves to this electrophile, and they made this bond right here. But this is also a good leaving group. We'll be talking about good leaving groups and bad leaving groups, but this is a good leaving group. And so it can also go in the reverse direction, where these electrons become over here, and so it goes in the backwards direction. If you have a poor leaving group, then it's unlikely that this group here is going to leave and go back in the other direction. Okay, loss of a leaving group. Most leaving groups can function as nucleophiles, so these tend to be reversible. If we have a group that leaves, it can then attack and go in the other direction. Proton transfer. Technically, they are reversible, but if the pKa values are different, they may be functionally irreversible. So let's look at the pKa's. Here we have a butane, and there are 10 to the 34th molecules of butane for every water molecule. So there's so many more of these that this is so much more stable that it's not going to go in the other direction. Here we have pKa values that are closer in value, and so this could be reversible. Carbocation rearrangements are considered irreversible. And that is all for the chapter.